Hey guys, welcome to my channel and I'm back again with another really interesting video guys. Today's video's topic is knowledge graph. So yes guys, in my previous videos I have been talking a lot about RAG pipeline and how we can use AI to query data from a set of documents. But today we are going to talk about a similar topic but it is a lot different, and that's called as knowledge graph. And we will also see how you can actually implement that in a Google Colab notebook with a generative AI model, and that too with the help of LlamaIndex. Okay, so I hope you guys are excited for this. I'm excited too. Let's get started. So first of all guys, you can see on my screen I have got IBM page open and it basically posts a question: what is a knowledge graph? Okay, so let me tell you this thing guys. Knowledge graph is basically a set of relationships between entities. Okay, it is nothing but a set of relationships between entities. So let me give you a small example. Let's go to this chat GPT prompt and I'm actually show the with an example. So what is an example knowledge graph? So let's say you want to create a knowledge graph for J.K. Rowling, right? Now J.K. Rowling is a person. She is also an author. She has written many books of Harry Potter series and other fantasy genre. So these are some of the entities that are related to J.K. Rowling. First of all, J.K. Rowling herself, then the name of her books, the series, and also the characters in her books as well. Then we talk about the relationships, right? Now, what are the relationships between all these entities? So, first relationship that comes into mind is that J.K. Rowling wrote Harry Potter and the Sorcerer's Stone. So, basically, this is an actor, this is an entity, and it did this. Okay. Then we also have other relationships between entities like Harry Potter and the Sorcerer's Stone belongs to the Harry Potter series. So these words like belongs to, wrote, and all these words actually establish the relationship between the entities. So this is how it works guys. It is nothing but a relationship between entities. And you can also visually represent that as nodes, okay, where you can create one node that has J.K. Rowling in it, then you have got another node which has got Harry Potter written in it, and then you can create an arrow which basically says J.K. Rowling wrote this book. Okay, another similar example how it visually can be represented as, so for example something like that, right? So this author is an entity. So this author worked on programming. So let's say it wrote some programming books. This author also worked on writing. So he is a programmer and he is also an author. So he's also working on writing. Okay. So this is how knowledge graph actually basically looks. It is a set of nodes which are called entities, and then you have got arrows going through them, and those represents the relationship between those nodes. Now we know what is a knowledge graph. Now the question arises, why do we need it, right? Why do we even need something like knowledge graph? Because essentially what we are saying that we have a set of documents, okay? Let's say I have got a set of books and those books are Harry Potter books, and then I have got a set of other documents which are about the biographies or autobiographies of J.K. Rowling, right? And now I'm trying to set up a relationship between them, or basically I set up a generative AI engine which looks into all those books, queries them, and gives you certain answer, right? Now we can do that with RAG pipeline also guys. We don't need a knowledge graph for it. So let's say if I give you PDF of Harry Potter series and I give you a PDF of J.K. Rowling's lifelong history, you can give that as a document data to a RAG pipeline and the AI would be able to answer the questions, right? But it's not essentially the same, because what RAG pipeline is actually doing is it is just retrieving the data from that document, summarizing it, putting it in a good format and just giving it to you. It is very useful when you have got volumes and volumes of data of different formats like text, audio, etc., etc., where you really don't need to set up relationships between the entities, where you don't care if a certain document is actually related to another document. all you want is, this is my question, just search all these documents, find out which is the document that gives you the answer, take that text from it, summarize it, make it beautiful, and give me the answer. That's how RAG pipeline is going to work for you. But in a use case like this, where you actually want to ask questions about what genre did Harry Potter belongs to, right? Or you want a question who acted as Hermione Granger. So if you go as a RAG pipeline, you might actually find out in the Harry Potter series book who is Hermione Granger. But you have to go into a different document to actually find out which actress actually played that, right? So this is actually a question which is setting up relationships. And for that, knowledge graphs work the best because they actually make sure that all the documents that you are interacting to have a certain relationships already established, which gives the generative AI an edge when it's querying those documents. So that's the difference, guys. When you're using RAG pipeline or vector databases, you usually use it when you have got loads and loads of data, but you don't need to establish the relationship between them. And you need knowledge graphs when you actually have certain data which has some relationship and you need to establish that. Okay. Now these are certain, this was an overview of what knowledge graph is, how it actually works, an example. Now we need to also discuss certain key points. Just laying them out there, guys, although I think I have explained them using the example. So what are the few things that a knowledge graph has? First of all, it has got nodes and edges. So you can see in this example, you have got nodes and you have got edges. Okay. Then it has got the semantic relationships, right? Often we can see that we have got certain data which is actually not related to each other. It has got nothing to do with each other. And then you can't set up relationship between them, right? But if you have got data which actually is having some sort of similarity or some sort of relation with each other, you can find out the semantic relationships and actually show them in knowledge graph. So here you can see the words that are written on the array, on the arrow, are actually setting up the semantic relationship. Then the next feature it has is ontology and schema. So what is an ontology and schema? So basically, guys, knowledge graphs are based upon certain concepts. So if you are creating a knowledge graph, it essentially, I know it says some data is related to each other, but it is actually created in an environment which is talking about is one specific thing. So if I talk about Harry Potter and J.K. Rowling, we are actually talking about the fantasy genre series, or we are talking about books, right? So what we can say here is that knowledge graphs are usually based on certain similar topic where you can collect all the data related to that topic and set up relationship between them. So that's the schema, that's the ontology that it refers to. And the schema that you actually mention actually set up the rules for that. So for example, if I'm setting a schema that I'm having J.K. Rowling as an author and then I'm having all its books, there has to be a certain schema next to it, that obviously J.K. Rowling is the highest entity and the books are the entities which comes after J.K. Rowling, because she is the one who actually created those. So this is the thing, is that all these schema architecture actually depends upon what that whole knowledge graph is talking about. Okay. The next thing that we should know about knowledge graph is applications. Like I told you, why do we need knowledge graph? Knowledge graphs are essentially needed when you need to set up relationships between the data and you want that, you want more semantic output instead of just this is my question, give me an answer, right? So for example, when we are using Google's search engine and recommendation systems, etc., they actually use knowledge graphs, because when you are actually searching Google actually has all the data in itself and it has established loads of relationships between that data. So when you give it a query, it can exercise that relationship, take a knowledge graph, take your data, make a question, answer it in the best possible manner, collate that answer from multiple sources and give you in the best possible response, right? And then interoperability and integration. So obviously, guys, this is pretty much evident that knowledge graph connects things together, and those things can come from different data sources. So interoperability is actually the core of it. It is essentially used to connect different type of data sources together, establish relationship between them, and then give you the answer that can actually, expose you to multiple sort of responses, and give you the best possible answer. So these are some of the key points, guys, and this is essentially I wanted to talk about knowledge graph and what it is and why is it better, or why is it better for certain use cases. Okay, so now that we know about knowledge graphs, guys, and we know why we need knowledge graph and why we need vector databases like RAG pipeline, it is time for us to use LlamaIndex to actually create a knowledge graph, or actually use some documents and then query them with LlamaIndex using a knowledge graph object. Okay, so I know you guys are excited. Again, let's get to it. Okay, so this is my Colab notebook, guys, as you can see on my screen. And the first thing first that we are going to do in this Colab notebook is start installing the packages. So you can see on my screen that I am installing LlamaIndex LLM's groq. I am also installing LlamaIndex embeddings, and for that also I am using the Hugging Face embeddings. Okay, so these are some of the installations that we are going to use. Now let's go to using the knowledge graph and building it first of all. So to build it, we need certain imports, right? So you can see on my screen that we need certain imports like that. So we need simple directory reader. I don't think we need vector store index, but I'm not sure why it's there. But you can see that some of these imports we are definitely going to use. Some of them are unused, but we can always remove them in future. So we are going to use simple directory reader, guys, to actually read the documents from a directory, read multiple documents from the directory. Then we have got Hugging Face embeddings, because we are also going to use our knowledge graph with embeddings. We have got sentence splitter, just to split our sentence into multiple nodes, and then created multiple sentences that you can give as individual sentences or individual nodes to our knowledge graph. Then you have got the LLM model, which is groq. Then you have got the settings. Settings is just to set up the environment variable, which is where we are setting up the environment large language model as groq and environments embedding as Hugging Face embedding. Then important thing that we need, I'm importing simple directory reader again here, but it's needed. You only need to import it once. But yeah, the one thing that we need is knowledge graph index. So as I told you, we have got something called as vector store index, where we create an index, basically a directory, a marked directory of all the nodes of all the documents that we are reading through. Similarly, we need a marked directory of all the data that we have read through, all the nodes that we have created for which we want to build a knowledge graph. So we don't need a knowledge graph index. Okay. And then you need the graph store. So there is a simple graph store as well. Again, most of these attributes are actually parallel to what we have used in RAG pipeline, right? Because there also we are using a storage, and here also we are using simple graph store. Okay, so now that we are done with the imports, let's dive into it. So first thing you can see what we are actually doing is we are taking simple directory reader, and then we are reading data from the data folder. So let me open my Colab folders. You can see that this data folder basically has got two documents, and this is Paul Graham essays document, which I actually split it into two different text documents just to show them that we can show you guys that we can actually interact with multiple files at one time. And one is the essay.txt and one contains some of the notes that he gave. But all you have to do is give the directory name and load data. It is going to load all the documents in one go in the documents object. Now the next thing we are doing is we are getting the groq API key. So guys, groq is an AI inference platform which allows you to actually interact with your large language models with lightning fast speed by just sending a REST API call or just a API call. Okay. And for that, to access groq, you need an API key. So that's the API key that I have been using here. If you guys don't know how to obtain a groq API key, you can just watch my previous videos of groq that shows exactly how you can get your API key. It's pretty straightforward. Let's go to the next part, guys. You can see now the next thing we are using is we have got our groq API key. So we are putting that in the groq class object, and we are setting our model as llama 370 billion 8192. You can use different models. I think llama 3.2 3 billion per 1 billion parameter model is also available on groq, so you can use that as well. But just for this example, I use the 70 billion one. And then we are also creating our embedding model. For that, we are using a small sentence transformer model, which is all mini LX v2. Okay. Now we are just setting some of the environment things, like by default LLM model will be the groq llama 3 model. By default the chunk size is going to be 512, and by default the embedding model is going to be embed model. Okay. So you need to provide all these things so that it doesn't go to OpenAI. If you don't set these things, guys, what's going to happen is that it is going to by default start searching for the OpenAI key, and it will start using the OpenAI model. And if you want to use your own models, you have to set these settings. Okay. Yeah. Okay. So let's go next. So now what we are actually doing is we are actually creating a knowledge graph. And how do we create a knowledge graph, right? Then think of it like a human would think. I have got all the text data. Okay, to create a knowledge graph, what am I going to do? I'm going to take a pen, I'm going to take a paper, and I'm going to start drawing. I'm going to start drawing the nodes, I'm going to start draw the edges. Basically, I'm going to draw a graph. And exactly what this is doing, guys. So you can see that first we created a simple graph store, and then we created a storage context, and then we passed our graph store. And again, I have told this before, guys, that storage context is one of the important things that we have in LlamaIndex. And storage context is also used for vector store index. That means in the RAG pipeline, where we just get this context that you can persist for later use. So that's very, very important, guys, that once you have loaded your document, you have created an marked index, like a marked directory for it to search the data, it is very, very important that you store that index somewhere, because every single time you don't want to create that index. If your set of documents is not changing, it is best to just store that index somewhere, and then you can just load that index and just query it again with your LLM. Okay, and that's what we are doing here. We are creating a storage context, and we are actually storing our graph store object into it. And now we are going to actually take this storage context and update that with the knowledge graph index. Okay, so we are going to create a knowledge graph index from documents, pass your documents, pass the max triplets per chunk, and then pass your storage context. Okay, now this step can take a little bit longer because it is actually creating your knowledge graph. Okay, so it is just saying is that how many triplets, basically how many nodes, triplets of nodes it is actually creating per chunk, and then what are the documents it's actually taking. So depending upon the size of the documents and the number of the document, this can take some time. But essentially eventually your knowledge graph is going to get created. And now comes the best part, to query the knowledge graph. So here you can see that we have the knowledge graph index object with us. What we can do is just use the index object dot as query engine and just create our query engine object. Here we can mention include text as false, and response model is tree summarize. You can use different response models here, but we are using the summarize model because we just want a short and concise answer. Okay, and finally you can do query engine dot query, where the question is tell me more about interleave. So if you read through the Paul Graham essays, guys, they have actually talked about interleave, and he's an author. He has done some essays and some text, and this is what he is talking about. Finally we get the response, and here is what we have we are displaying the response. So interleaf is basically a software for creating documents. Okay, so this guy Paul Graham was also a coder and was also an author. So he is talking about this software, and that's the software that he has written about in these documents. Okay, now you can see that there is another query that we are asking here. Tell me more about the author who worked on at interleaf. So you can see how cleverly they have posed the question. They have established that there is an author who wrote something about interleaf. So they are trying to establish that relationship. You can see that knowledge graph gives you the answer that the author worked on writing things in the scripting language, which was of a dialect Lisp at interleaf. Okay, so it knows that some author actually worked on interleaf. It knows what that author did, and then establishing that relationship, it gives you the best answer and also in a summarized form. Okay, so here we are actually querying multiple documents, multiple chunks, trying to find out the correct data, summarize it, establish the relationship, and send you the result. And that's why it's pretty good. Now you can also query your knowledge graph with embeddings. Okay, if you want to include embeddings into it, all you have to do is just write the include embeddings equals to true. And what you can do here is you already have your embedding model set up by default using settings.embed model. So it is going to take that embedding model into consideration, and it can further refine your result, because embedding model can chunk your data and convert your data into a vector form much easier in a much more efficient way. Okay. So now you can do same thing index as query engine. You can set up the embedding mode as hybrid. You can do the similarity top k equals to 5, where it actually looks into the top 5 best searches and then it finds out a result for you. And now we are doing this query, tell me more about the author who worked on at interleaf. You can see that it pretty much give you the same result. So worked on writing things in the scripting language, which was the dialect of Lisp at interleaf. So not much of a different, but maybe when you have got loads and loads of documents where you have got a complex question, maybe I think the the embedding model can give you better answer. Also in the cases where your document is very vague, like your question is very vague, there can be multiple answers to it, multiple similar text related to it, I think maybe the embedding model can work better. Okay. Now, how you can build the graph and manually add the triplets. So until now what we are doing is, we are actually just sending it the documents, and our LlamaIndex APIs are actually creating the triplets for us. So this HTML document was actually generated by LlamaIndex itself. So when we gave it the documents, it actually generated this knowledge graph for us. What if that you want to add your own triplets, you want to add your own nodes? How you can do that? And that you can do that again with the help of knowledge graph index class object only. And what we are doing here is, first of all, we are getting a sentence splitter, just some boilerplate code for splitting our documents into sentences. Then we have got a node parser, because obviously guys, you are building it manually, you need the nodes, right? You need to specify it. It's not gonna find it automatically, because that's not what we are trying to do. So you have got your node parser dot get nodes from documents. So this is how you get the nodes. Then you create a knowledge graph index, which is pretty much empty at this moment. And now you start creating the keyword mappings and nodes manually. Okay. So let's say the first node has got certain mappings, that author worked on writing, author worked on programming. And then for every single tuple in this node, in this set of nodes, you actually use your index and you do an update, that upsert triplet and node. So you just basically are manually inserting a tuple of nodes into your knowledge index. But just remember, if you are doing it guys, that you have to specify it in this particular format, that you have got entity, then you have got what it worked on or what it did, and then you have got the second entity. Okay, so you have to work it like a triplet, that entity, relationship, entity. Okay, then you have got the second node triplet, which also you are eventually adding into your index. And now your index is having only the manual nodes created. So now your query engine basically says, tell me more about interleaf. And here you can see that we added few nodes for interleaf, and the answer basically now is taking the answer response from these manual nodes, and it says interleaf made software for creating documents and also added a scripting language. So you can see that it took both of these things together and took the relationship as well and gave us the correct answer. Now you can actually visualize this knowledge graph using the pyrus library, and you can see that using this small piece of code you can actually visualize it, and that's how I'm visualizing it with example.html file which gets created. And this is how you can see how the entities look and how the relationships look. Okay, so guys, that was the video. Okay, in conclusion, if you want your documents to have certain relationships with them and you want to respect that relationship and give you answer on the basis of that, I think knowledge graph is a really good idea, and you can use that now pretty effectively with your generative AI. On the other hand, guys, if you don't have to maintain certain relationships, you don't want to maintain the semantic part of it, then you can just use a simple vector database, create a RAG pipeline, and just create a question answering application. But both of these are pretty straightforward to make. And I'm also going to share with you guys this particular notebook that actually I referred it from the LlamaIndex documentation only, but I have ran this notebook on my machine and it works perfectly. Okay, so thank you so much guys for watching this video. If you guys actually want to support my channel, then you can actually give me a super thanks, which is right down at the bottom right corner. And guys, if you want to join my channel, that would also support my channel a bit. In the end, guys, if you guys like this video, then please do not forget to like this video and share this video with your friends. If you have any questions, comments, suggestions for me, please do write down in the comment section below. I would be really happy to address them. And guys, if you have not yet subscribed to my channel, please do subscribe and hit the bell icon for future notifications of more such programming and coding related videos. I'll see you guys in the next video, guys. Until then, take care and bye bye.